Alright, here we have a series and parallel pipe problem. All of these examples that I'm going to do are going to be straight from the review sheet that Dr. Parr posted. It's just labeled several solutions for test 3 problems. And yeah, so basically what I've done here is written the two equations for parallel and series beta values. That's actually not correct. That needs to have a square root. Okay, so now it's correct. So I've written the parallel and series equations here, and this is our diagram, and we are given that Q3 equals 2 CFS. We're asked to determine Q6. So there we go. So when I think about these kind of problems, I work from the outside in to kind of figure out what's going on. And I drew kind of like a flowchart type thing right here. This first part here is I'm seeing that from to get from A to B, the water has to go through pipe 1, and then somehow get through 2 through 8, and then through 9 to get to B. Okay, cool. So that's like the macro, the biggest level possible. And then next we have this 2 through 8 thing, and we have it goes through 2, 3, and then 4 through 8 in parallel. And again, this first part is in series. The third part, we're trying to figure out what's going on between 4 and 8. And we have 4, 5 through 7, and then 8. And then finally, 5 through 7 is this thing here at the bottom. So basically, just kind of look at this. This is just the way that my mind works when I look at these kind of problems. I figure out what's going on the macro level, and then just kind of work from the outside in. But then we need to work from the inside out in order to find what we need to find. This problem is actually a little bit different because it's given Q3, so we don't actually have to do a whole lot of work. Oops. And yeah, usually you're going to be given the system discharge instead of the series the discharge in one of the pipes. Another thing to note, this is actually kind of a really important concept for this. For these type of problems, for pipes that are in parallel, the head loss is equal, but the discharge is not. So for this bottom part right here, the head loss is going to be the same for pipes 5, 6, and 7, but the discharge between those pipes is not the same. And similarly for series, it's the opposite actually, is the head loss is not equal, but the discharge is equal. It makes sense because like each one of these 5, 6, and 7 are going to have different beta values, and if you'll remember the equation, Q equals square root of the head loss over the beta value, and that's for like an individual pipe. So actually we're going to use this at the end, so the head loss of 6 and Q6 and beta 6. So yeah, it makes sense because one has to change and the other one doesn't have to change, I guess. Anyways. So yeah, those are just two important little tips to note for these kind of problems is when you have to set things equal to each other. Yeah, you can use this little handy cheat sheet or whatever. So now we have this table over here. It's the exact same thing as this table right here, but I just made it larger. And so yeah, let's get started. So first we have to work from the bottom up, basically, in this kind of problem. So we have beta 5 through 7, which is just the beta of this whole parallel thing right here. And remember, if we have parallel, we have 1 over beta 5 plus 1 over, or square root of beta 5 plus 1 over square root of beta 6 plus 1 over square root of beta 7, all to the negative 2 power. And that is, these values are, let's see, 3, 4, and 5 respectively. And we get the value of 0.43 for the beta value for this whole section here. Now we, for series, we're going to find beta 4 through 8. And all that is beta 4 plus beta 5 through 7 plus beta 8. We'll just remember these two equations right here. Those are pretty much your bread and butter for this kind of problem. We just have to plug numbers into the equations and hope to get it right. So for beta 4 we have 9 plus our middle thing, which is 0.43, plus 2. So we get a value of 11.43, and that is beta 4 through 8. Next we have 2 through 8. So beta 2 through 8 is 1 over beta 2. Oops. Beta 2 plus, or square root of beta 2, 1 over square root of beta 3 plus 1 over square root beta 4 through 8. All that raised to the negative 2 power. And we have beta 2 is equal to 8, so we have 1 over square root of 8. Beta 3 is equal to 7. And then beta 4 through 8 is 11.43, all raised to the negative 2 power. And that's going to give us a value of 0.95. Okay, now we finally do the very last thing, which is beta 1 through 9, which is the same as beta total, which is simply beta 1 plus beta 2 through 8 plus beta 9. And beta 1 is 5, 2 through 8 is 0.95, and beta 9 is 6. So we get a beta total value of 11.95. Now, I guess we can plug these values into our little table up here. So we have beta 5 through 7 was 0.43, and all these numbers will carry over, so we have 9, 7, 8, 5, and 5, 2, and 6. Next we have 4 through 8, so we include this one. All those, and we get, oh, that doesn't go there. That's included in 5 through 7. So this is 11.43. Then we have 2 through 8. So these again will carry over. So we have 7, 8, 5, and then 6 at the bottom. So now we have all of these, which is 0.95. This is basically what you're going to be asked to do on an exam or homework, I assume, is just draw a table like this and show your thought process and just how you work the problem, basically. And this gives us an idea of like, okay, so we computed this value first, and then this value, and then this value, and then this value. It shows how you work the problem. So next since we're given Q3 equals 2 CFS, we're going to move our work down here. So we have Q, or actually I'll rewrite that equation as the head loss of 3 is equal to beta 3 times Q3 squared. And beta 3 is 7, and the Q is given in the problem as 2. So we get a head loss at 3 of 28 feet. And again, if we'll remember here, in this table here that I've made, when things are in parallel, the head loss is the same. So if we're looking at this thing right here, if the head loss through 3 is 28, that means the head loss through 2 is 28, and the head loss of 4 through 8 is also 28. So we can write that as the head loss of 3 is equal to 28, which is also equal to the head loss of 2, which is also equal to the head loss of 4 through 8. So that's, we have that. We can also calculate Q2. So Q2 is equal to square root of the head loss of 2 over beta 2, which is the head loss of 2 again, since we set all these equal, is 28, and beta 2 is 8. And that is equal to 1.87 CFS. And then we need to find Q for 4 through 8. And that's the head loss of 4 through 8 over beta 4 through 8. And we have both of these values. Again, 28 for the head loss because it's equal to these, to head loss of 3 and of 2. And beta 4 through 8 we calculated here to be 11.43 square root, and we get a value of 1.57 cubic feet per second. Now we can find Q total, which is simply, so Q total means the Q through the entire system, which if we look at this one, that means since these are in series, if you'll remember from down here, in series Q is equal, so that means Q of 1 has to equal Q of 2 through 8, which has to equal Q of 9, which equals Q total. So if we write that in this equation, we have Q total equals Q1 equals Q9 equals Q2 through 8. Yep, and then Q2 through 8 is equal to, so we're in parallel now, so all these Q's are not equal. So we have, which is equal to Q2 plus Q3 plus Q4 through 8. This is just splitting up Q2 through 8 into its 3 components. And then if we write these 3, because we just found all 3 of these, like right here, and then that goes there, and then Q3 is known. So we have 2 is 1.87, 3 is 2, which is given in the problem statement, and the last one, 4 through 8 is 1.57. Add those all together, we get 5.44 CFS, and that is the discharge through the entire system. Now, we have the Q through the entire system, so we can find the head loss throughout the entire system. So we have head loss total is equal to beta total times Q total squared. And beta total is right here, we found that is 11.95. And Q total we just found, which is 5.44. And that is squared, and we get a value of 353.6 feet. And that is the total head loss of the system. And if we look in our problem statement, it actually also asks us to find Q total, which is this last sentence, the difference in the water surface elevation between ponds A and B. That's another way of saying the head loss from A to B, which is head loss total. Now, that we have that, we are trying to find the head loss of, or we're trying to find Q of 6. So Q of 6 is, where did I write that? Right here. So I'm going to move that equation over here. So Q6 is equal to the square root of the head loss of 6 over beta 6. So we already have beta 6. We calculated that, or sorry, that's given in the problem. And now we need to calculate the head loss of 6. Now the head loss of 6, this is where the problems start getting really tricky, is when you have to, like, these problems are actually really long and pretty, they can get really confusing when you have pipe systems like this. So we have the head loss of 6 is equal to the total head loss, which is 353.6, minus the head loss of 1, minus the head loss of 4, minus the head loss of 8, minus the head loss of 9. And if we expand these, we have beta 1 Q1 squared minus beta 4 Q4 squared minus beta 8 Q8 squared, minus beta 9 Q9 squared. And from here we can just plug in all of our values for beta and Q. So we have 353.6 minus beta 1, which is 5. Q1 we found somewhere around here, right here. Q1 and Q9 are the same as Q total, so that's 5.44. 5.44 squared. Beta 4 is 9. And then Q4 is, if we'll remember, is in series with, right here, it's in series with 4 and 8. And we calculated beta 4 and 8, or Q4, or 4 through 8 right here. So that's all the same. So we have 1.57 squared. 8 is also the same, or not the same beta. Beta for 8 is 2, and the same discharge. Beta 9 is 6, and then it has the same Q as beta 2, or beta 1. And finally, if we do all this math, we get the head loss of 6 to be 0.956 feet. And then we can plug this into our equation up here. So we get Q6 is equal to the square root of 0.956 over beta 6, which is 4. Finally, we get our answer of Q6 to be 0.489 CFS. This is probably like the absolute hardest question you could be asked as far as these problems go. You're not given the total system discharge, you're given like a random one that's in the middle. In this problem it was number 3. But yeah, these are definitely some problems that you need to practice, especially for the final and for this test and just in general. So yeah, hopefully this helped. You might need to watch this again, and you might need to play it on like 1.5 times speed, because I'm sure this is going to take a while. But yeah, hopefully this helped, and yeah, good luck on your test.